7.6 is exponential functions. 7.6 is exponential functions. Some functions model an initial amount that is repeatedly multiplied by the same positive number. What's repeated multiplication? How do I write repeated multiplication? Exponents. That's the reason why these are called exponential functions. Okay? In the rules for these functions, the independent variable is the exponent. The independent variable is the exponent. Okay? So an exponential function is a function in the form y is equal to a times b to the x power, where a is not equal to 0, b is greater than 0, and b is also not equal to 1. Oh, and x is a real number, okay? Now, when you're looking at your exponential graphs, when you're looking at the graphs, here is what it looks like when it's a positive base with, positive base greater than 1. Looks like this red one, this red graph. If this is a negative with the base greater than 1, it's a negative greater than 1, kind of weird. The graph swoops downward, okay? This is what it looks like when we have a fraction as a base, okay? The fraction as a base, a positive, swoops up like this, and if it's a negative fraction as a base, swoops down like that, okay? Please sketch that into your notes. If all of the x values in a table of values have a constant difference and all of the y values have a constant ratio, then the table represents an exponential function. Problem 1 says identifying an exponential function. And we want to know, does the table or rule represent an exponential function? So here's our table. Okay? So, first, it says if all of the x values in a table of values have a constant difference, so we want to look at the difference in the x's. So here, 1 to 2, 2 to 3, and 3 to 4. Each time, we are going to do what? Add 1. Add 1. Add 1. Add 1. Now we have to check the y values. It says all of the y values, if all of the y values have a constant ratio, then the table represents an exponential function. So now we're going to see what can I multiply to get from 1 to 1, 1 to 3, and 3 to 5. So here, to get from 1 to 1, we're just going to multiply times 1. To get from 1 to 3, we're going to multiply by 3. And to get from 3 to 5, we're going to multiply times 5/3. So, going back to our rule, it says the x values of a table have to have a constant difference. So, that's good, right? All of our x's are the same, right? I mean, all of the x patterns are the same. It also says that all of the y values must have a constant ratio. Are my ratios the same? They are not the same. So is this an exponential function? This is not an exponential function. Very good. Not an exponential function. Because y values do not have a common ratio. Sorry, constant ratio. Constant. Let me put that in red. My bad. If my y values had a times 2 times 2 times 2, then it would be a constant ratio. Then it would be a constant ratio, and then it would be an exponential function. Has everybody got that? All right. So how about letter B? Y is equal to 3 times 6 to the x power. Is that an exponential function?
Yeah.
Why?
Because it already has the
It's already in the form that it's supposed to be in, but also, where is my independent variable?
X.
It's the exponent, right? So your x, your independent variable, is your exponent, which makes it an exponential function. Okay, very good. And that's what we'll write. The independent variable is the exponent which makes it an exponential function. Problem 2 is evaluating an exponential function. Write this down, please. An initial population of 20 rabbits triples every half year. The function, f of x, is equal to 20 times 3 to the x power gives a population after x half-year periods. How many rabbits will there be after 3 years? So what's the important information in this problem? Yeah? 20 rabbits. If you look, that's 20 rabbits is the initial value, right? That's the initial value. Every half year, right? Triples every half year. And how many years are we looking at? We're looking at 3 years. So if we're looking at 3 years, how many half years do we have?
6.
Very good. So that means that x is equal to 6. Is everybody clear with that? So now, all you're going to do is you're just going to take your x and you're going to put it into your function. Okay? So we've got f of 6. Remember, that's the name of the function. It does not mean f times 6. That's f of 6 is equal to 20 times 3 to the 6th power. And now you just simplify. So we have 20 times, what's 3 to the 6th power? All right, so 3 to the 6th power is 729. And then, of course, you multiply 729 times 20, and what do you get?
14,580.
Very good. 14,580. What? Rabbits. Rabbits.
Rabbits.
Problem 3 is graphing an exponential function. Graphing an exponential function. This might take a little bit of time. Okay? We have y is equal to 0.5 times 3 to the x power. The rule is right here. It's the 0.5 times 3 to the x power. Now when we're graphing, of course, we want to have some positives, some negatives, and 0. Okay? So, let's do -2, -1, 0, 1, and 2. When I substitute in, I've got 0.5 times 3 to the -2. When you have 3 to the -2, all right, you cannot put that in the calculator.
Yeah.
The laws of exponent says that you're going to flip that, okay? I'm trying to get the blue, but you're going to flip that, and it's going to become 1 over 3 now to the +2.
Oh.
Okay? So, this is going to be 1 over 3 squared. All right, so we've got 0.5 times, now this we're going to flip it, we're going to get the reciprocal, and the exponent becomes positive. So that's going to be 1 over 3 squared. 3 squared is equal to 9, right? Okay, so 0.5 times 1/9. When I multiply fractions, I just multiply straight across, correct? So this is going to be 0.5 divided by 9, which gives me what? And we're going to round to 0.06. Okay? So here we have 0.06. Is everybody clear? Let's do another one. Okay? Here we have 0.5 times 3 to the -1. Again, this negative exponent is going to, we want the reciprocal. We want to flip it. And once you flip it, the negative exponent then becomes positive. Very good. So we have 0.5 times 1 over 3. Now you're just going to multiply straight across. You see that? Because that's just fractions. So we have 0.5 over 3, which gives you what? Well, round, this is going to be 0.17. 0.17. Is everybody clear with that? All right. So now we've got 0.5 times 3 to the 0 power, the 0 to the 0 power. Any number raised to the 0 power is equal to? 1. Very good. So this is going to be 0.5 times 1 times 1, and this is 0.5. All right. So now we're going to put in ones and the +1, +2. You should have no problem with that, right? 0.5 times 3 to the first. So 1/2 times 3, 1.5. Now we have 0.5 times 3 squared. 1/2 times 9, 4.5. Got it? All right, so now you're going to graph on your coordinate grid. So we've got -2, comma, 0.6, which is that right here, very close to the axis. We have -1, comma, 1.7, which is a little farther away from the axis. We've got 0, comma, 1/2, right there. We've got 1, comma, 1.5, and 2, comma, 4.5. 1, 2, 3, 4.5. So your graph looks like that. All right? Very good. Except you should try not to let it touch the x-axis. Okay? Now, I want to show you what it would look like if now we had a negative initial value. All right, so here we did our substitutions, and we end up with a negative 0.06. We have a negative 0.17. We've got a negative 0.5, negative 1.5, and a negative 4.5. Now when you graph this, all right, so now we have our negative values, our negative initial value. So all of our y values are negative. So this is what the graph of the negative looks like. So here we have a positive a, looks like this, and this one is a negative a. All right, problem 4 is graphing an exponential model. Computer mapping software allows you to zoom in on an area to view it in more detail. The function f of x is equal to 100 times 0.25 to the x power gives you models the percent of the original area the map shows after zooming in x times. Graph the function. So here, the initial value is 100%. That is the initial value. Okay, you will see that the initial value is our A. Oops. The initial value is our A. All right, so again, here we substituted our x values. Now, the reason why we only have positives here is because in a real life situation, you will not be zooming negative times. You cannot zoom negative times, so that's why we only have positives. So we substitute in, we get our y values, and then we plot the points. So you're going to graph 0, 100. So that's the 100% mark. We've got 1, 25, 2, 6.25, 3, 1.56, and 4, 0.39. Please notice that we're going to get closer and closer and closer to the x-axis, but we're not theoretically going to touch the x-axis at all. We're just going to get closer and closer and closer and not touch it. And that's it.